Let's begin with Chapter 2, Recognizing and Identifying the Hazards. In this lesson, we will be discussing the objectives for situational awareness by describing how to approach a scene size-up with potential hazardous materials involved, identify and describe the types of containers that are often used to contain hazardous materials, describe the purpose and types of various transportation and facility markings for hazardous materials, and identify and describe the 4 routes of entry harmful substances take in the human body. Chemical abstract services. Databases on chemical information. Chemical usage and storage can come from warehouses, hospitals, laboratories, industrial occupancies, residential garages, bowling alleys, home improvement centers, garden supply stores, and restaurants. With the community response plan, we need to identify the kinds and quantities of hazardous materials, develop plans for high hazard occupancies, provide guidance on response procedures, and locate key personnel. Identifying chemicals. When using the identification systems, they can include placards, labels, other signage, other methods, detection devices, and eyewitness accounts, visible indicators. For your scene size up, you want to approach from a safe location and direction by approaching from uphill and upwind, using binoculars, assessing the scene, question anyone involved, interpret other clues, and plan for addressing the incident beginning with SIN, safety, isolate, and notify. With safety, you want to read the scene, interpret available clues, make informed decisions, operate safely, stop and pay attention. Initial first steps, stay uphill, upwind, and out of the problem. Obtain a briefing from those involved in the incident prior to acting and understand the nature of the problem and factors influencing the release. An attempt to make a positive identification of released substances. Isolate. Isolate and deny entry to the scene. Establish a hot zone and separate people from the problem. You will also need to use references such as standard operating procedures, emergency response plans, emergency response guidebooks. And establish a command post. Determine response objectives and formulate a basic incident action plan. Identify and remotely secure potential ignition sources. Notify. Decide whether to notify anyone else and keep current and comprehensive contact lists of local, state, and federal resources and understand who has key players are in your jurisdiction. And be familiar with the communications equipment, radio frequencies, and protocols for using your authority's jurisdiction's communications equipment. Indicators of a hazardous material incident could include information from the initial dispatch or persons on the scene, your knowledge of the response area, clues that could be even seen or heard. So, detecting whether a hazardous substance is present should be guided by your department's SOPs, your level of training, your information gathering, efforts at the scene, and your senses, your sight and sound. Let's talk now about containers. The definition of a container is any vessel or receptacle that holds a material, type, size, and material provide. Important clues also. Usually there is no correlation between drum color and its contents. Representative containers can include steel or polyethylene drums, bags, high-pressure gas cylinders, railroad tank cars, plastic buckets, above-ground and underground storage tanks, and pipelines. Stainless steel containers could hold particularly dangerous chemicals within them. Dewar containers are an example of a steel container. They are used for storing cold liquids and look closely at the container and form an opinion about the contents inside. With drums, they are barrel-like containers which are used to store food-grade materials, corrosives, flammable liquids, grease even. These drums may be constructed of low-carbon steel, polyethylene, cardboard, stainless steel, nickel, and the nature of the chemical dictates the construction. Closed-head drums are permanently attached lids with 1 or 2 small openings or bungs at the top. An open-head drum, though, has a removable lid that is fastened to the drum with a ring. Carboys are glass, plastic, or steel containers that can hold 5 to 15 gallons of product. They're often placed in a protective wood, foam, fiberglass, or steel box to prevent breakage even. Cylinders are uninsulated compressed gas cylinders. Store substances such as nitrogen, gas, helium, and oxygen, and ranges in sizes and variable internal pressures are present. High pressure creates potential for danger, because when these vessels have ruptured, they will launch like a rocket with nothing stopping them until the pressured gas inside it is expelled completely. With propane cylinders, they are lower pressure and they contain liquefied gas which is subject to BLEVE. Dewar containers are thermos-like vessels designed to hold cryogenic liquids. Typically, cryogens include oxygen, helium, and hydrogen, argon, and nitrogen. Cryogens pose a substantial threat if the container fails to maintain low temperatures. And cryogenic containers usually have two pressure relief devices, a pressure relief valve and a frangible, easily broken metal disc inside. Transportation and facility markings enable responders to identify these release chemicals and indicate the presence of hazardous materials. They also provide clues about the substance as well. SDSs, or safety data sheets, provide basic information about the chemical makeup of a substance, the potential hazards it can present, and appropriate first aid in the event of exposure, and other pertinent safety information. These SDSs typically can include the name of the chemical, including any synonyms, physical and chemical characteristics for the material, physical hazards of the material, health hazards of the material, and signs and symptoms of exposure, as well as routes of entry. The permissible exposure limits provide a responsible party contact and precautions for safe handling of the product, applicable control measures, emergency and first aid procedures, and appropriate waste disposal. And make sure to ask a representative for SDS for any spilled materials present. This here is an example of an SDS for anhydrous ammonia, only showing the front page of it. The National Fire Protection Association 704 marking system, which is characterized by a set of diamonds found on the outside of buildings, doorways to chemical storage areas, fixed storage tanks, and designed for fixed facility uses only. It uses diamonds shaped symbol broken into 4 smaller diamonds within it. Each diamond contains a numerical rating in the range of 0 to 4. The blue diamond at the 9 o'clock position indicates health hazard. The red diamond at the 12 o'clock position indicates flammability. The yellow diamond at the 3 o'clock position indicates instability. And the white diamond at the bottom position has no number rating but contains only special symbols. The NFPA 704 marking system differs from the U.S. Department of Transportation's marking system. The DOT system is used when materials are being transported only, and 704 hazard identification system is used for fixed facility uses only. Within the Hazardous Materials Information System, or HMIS, uses numerical hazard rating and colored horizontal columns. It gives personnel information to work safety around the chemicals. It includes training materials for workers not required by law and provides guidance about protective clothing requirements and differs from 704 marking system. 704 is intended for responders, where HMIS is intended for facility employees. So in this lesson, we've seen a concurrent theme in regards to placarding and marking of hazardous materials for transportation use. But there's one entity in the United States that is exempt from all this, and that's the U.S. military. The military hazardous materials, weapons of mass destruction markings. Hazardous materials are divided into 4 categories for them. Division 1, mass detonation hazards. It's identified by number 1 printed inside an orange octagon. Division 2, explosion with fragment hazards, identified by number 2 printed with an orange X. Division 3, mass fire hazards, identified by number 3 printed inside an inverted orange triangle. And Division 4, moderate fire hazards, identified by number 4 printed inside an orange diamond. With chemical hazards, they are depicted by colors. Toxic agents are red, harassing agents yellow, and white phosphorus is white. The specific personal protective gear requirements are even identified using pictograms. Military shipments containing hazardous materials, or WMDs, are not required to be placarded. So whenever anything is shipped through commerce, transportation, whether road, rail, boat, or airway, it all has to have certain paperwork. Shipping papers are required whenever materials are being transported, include the names and addresses of the shipper and its receiver, identify the materials being shipped, the specific quantity and weight of each part of the shipment as well. The bill of lading or freight bill is shipping papers for road and highway use for transportation. It's usually located in the cab of the vehicle and is required by law and may require additional information about the hazardous material substance inside. Packaging group destinations: Packaging Group 1 for high danger, Packaging Group 2 has medium danger, and Packaging Group 3 is minor danger. Waybills are shipping papers for railroad transportation. They consist of a train list or list of contents in every car of the train. The conductor, engineer, or designated member of the train crew will have a copy present. And dangerous cargo manifests are used on marine vessels and are usually kept in a tube-like container in the wheelhouse with the captain. The air bill is used for air transportation. It's kept in the cockpit and it's pilot's responsibility at all times. One thing not included in that is something that is in a new category of itself: pipelines. With pipelines, the length of pipe for conveying liquid or flammable gases, and pipelines indicate many present and unique challenges and hazards because they're often buried underground, but some areas may have them above ground in remote areas, and the subject matter experts may be required to assist in this issue. Pipeline right-of-way is an area extending from a certain number of feet of either side of the pipe. The company that owns that pipe maintains this right-of-way and must place warning signs at regular intervals. Warning signs can include the warning symbol, the pipeline's owner's name, the emergency contact number even. And vent pipes are inverted J-shaped tubes which provide pressure relief for natural venting. They're clearly marked and located approximately 3 feet above the ground. So now you know what the chemical is, and you know what the placard number says or the UNNA number, but you need to know more about it. How are you going to look that up? That comes from the ERG book. The ERG, or Emergency Response Guidebook, provides information on several thousand chemicals. It does not list all chemicals that can be shipped by land, sea, air, or rail. In most cases, placards are required only when a shipment weighs over 1,000 pounds. Some chemicals require labels or placards in any amount: explosives, poisonous gases, water-reactive solids, high-level radioactive substances. Placards are diamond-shaped indicators placed on all 4 sides of the highway transportation vehicles, railroad tank cars, and etc. that identify a broad hazard class. Labels are smaller versions of these placards, and they're placed on all 4 sides of the individual box or smaller package, and relate only to the potential hazard within the package. The 4-digit United Nations UN number may be required on some placards. It identifies specific materials being shipped. A label is a smaller version of the placard and is placed on the boxes or smaller packages that may contain hazardous materials. The ERG is used for small spills, a leak from one small package, or a small leak in a large container. It could be a large spill or a large leak from a spill from a large container or package. A spill from a number of small packages even a spill from a 1-ton cylinder, a tank car, or rail car. There are 4 colored sections within this book. The yellow section lists more than 4,000 chemicals numerically by UN number. Entries include the chemical name and the emergency action guide number. The blue section lists chemicals alphabetically by name, and entries include the emergency action number and the identification number. The orange section is organized by guide number. It provides general hazard class, fire explosion hazards, health hazards, and basic emergency actions. And the orange section in the ERG is organized by guide number. The green section, organized numerically by UN ID number, provides initial isolation distances for certain materials. Includes chemicals highlighted in yellow and blue sections. Also includes water-reactive materials that produce toxic gases, toxic inhalation hazards, chemical warfare agents, and danger water-reactive materials. Other recommendations on size, shape, and protective action zones as well. The green section of the ERG is organized numerically by UN ID number and provides the initial isolation distances for certain materials. Now let's talk about chemical families and divisions recognized in the ERG. DOT Class 1 explosives. 1.1 explosives with mass explosion hazard. 1.2 explosives with a projection hazard. 1.3 explosives with a predominantly fire hazard. And 1.4, explosives with no significant blast hazard. 1.5, very insensitive explosives with a mass explosion hazard. DOT2, gases. 2.1, flammable gases. 2.2, non-flammable gases. And 2.3, toxic gases. DOT Class 3, flammable liquids and combustible liquids in the United States. DOT Class 4, flammable solids, spontaneously combustible materials, and dangerous when wet materials and water-reactive substances. 4.1, flammable solids. 4.2, spontaneously combustible materials. 4.3, water-reactive substances and dangerous when wet. Class 5, oxidizing substances and organic peroxides. 5.1, oxidizing substances. And 5.2, organic peroxides. DOT 6, toxic substances and infectious substances. 6.1, toxic substances. And 6.2, infectious substances. Class 7, radioactive materials. Class 8, corrosive substances. And Class 9, miscellaneous hazards, materials, product substances, or organisms. There is also a dangerous placard that indicates more than one hazard class is contained within the same load. Some chemicals are more harmful than others, and all it takes is simple routes to get into the human body. Harmful substances' routes of entry into the human body. The characteristics that will affect the human parameters and potential health effects of those exposed to the materials can include concentration of the material, temperature of the material at the time of its release, under pressures under which the substance was released, age, gender, genetics, and underlying medical conditions of the exposed person. When rendering medical care, NFPA 473, the standard for competencies for EMS personnel responding to hazardous materials, weapons of mass destruction incidents, says care is usually performed in a safe area in the cold zone away from the hazard after decontamination has taken place. Chemical substances can enter the human body in 4 separate ways: inhalation, absorption, ingestion, and injection. Toxicology is defined as the study of adverse effects or of chemical or physical agents on living organisms. Inhalation. Harmful substances enter through the respiratory system. They transfer quickly through the lungs to the circulatory system, and lungs cannot be decontaminated. The respiratory system is vulnerable to attack from a wide range of substances. Responders must wear appropriate respiratory protection when providing care or responding. Positive pressure, open circuit, self-contained breathing apparatuses, or SCBAs, full face or half face, air purifying respirators, or APRs, may be required in certain situations, but they do not provide oxygen to the responder. Respirators are also lighter than SCBAs and more comfortable to wear, and usually allow for longer working periods than SCBAs do. Determine the type of respiratory protection needed. Consider spore size of an anthrax incident. Wear an SCBA or at minimum a full-face APR with P1000 filtration. Infectious pathogenic microorganisms capable of causing an illness are an example. Contagions capable of passing an illness to another person. Particle sizes larger than captured in the nose and upper airways could be an issue. The smaller particles may work deep into the lungs, which can never be removed. When airborne contamination is encountered, understand the nature of the threat. Evaluate the respiratory protection available and decide if it provides adequate protection for the incident. Absorption, the process by which substances travel through the body tissues until they reach the bloodstream. Skin, eyes, nose, mouth, and intestinal tracts are part of this equation. Skin can be pierced by many chemicals. Asphyxiants prevent the body from using oxygen and causing suffocation. Carcinogens cause cancer. Responders must constantly evaluate the possibility of chemical contact. Consult the ERG for the SDS for response guidelines. Use chemical protective clothing if turnout gear does not offer adequate protection to you. With ingestion, it is the absorption of chemicals through the gastrointestinal tract. You must wash up after rotating out of a building to limit your exposure, and contamination can spread from hands to food to the gastrointestinal tract. With injection, exposure can come through open cuts and abrasions, and realize this whenever you will work in the compromised state even. Address cuts or open wounds before reporting for duty. Open wounds provide a direct portal to the bloodstream. In summary, approximately 83 million organic and inorganic substances are registered for use in commerce within the United States, with several thousand new ones being introduced each and every year. Identifying the kinds of quantities of hazardous materials used and stored by local facilities should be an integral part of any comprehensive community response plan. All responders must interpret visual clues effectively to improve their ability to safely operate at an incident, and all responders should be able to recognize the various container profiles and understand the general characteristics of materials that may be stored inside each type of container. All responders should also be able to name, understand, and locate the various types of shipping papers on various modes of transportation. When used correctly, various marking systems indicate the presence of a hazardous material and provide clues about the substance itself. And all responders should be able to demonstrate proficiency when using the Emergency Response Guidebook. It is important to know how to obtain an SDS document from various sources, including everyone's own department and the scene of the incident itself, or the manufacturer of the material. And this is the end of Chapter 2.